Hi folks, welcome back. So of course we all know OpenClaw blew up over the last couple of months. And over that time it has also inspired a number of other projects which try to do the same thing. They're called claws, which is kind of fun. What I want to do in this video is actually look into the internal architecture and implementation of OpenClaw and a few other popular claws because I think it can teach us a lot about how to build these full stack personal agents. The thing is that OpenClaw now is really huge. 5,000 source files. I think it's pushing 500,000 lines of code. And it's very monolithic in that all its functionality is in one large package. And I'm interested in looking at the internal architecture and seeing what kind of modularity exists or could exist. And also seeing how some of these other claw variants chose different points within that design space. One anchoring analogy I want to use for this is Linux distributions, things like Arch or NixOS or Ubuntu or Debian. They all make different design choices at various layers of their stack. Even if they pick the Linux kernel as the base, they build the Linux kernel differently. They make different choices at the low level, system level things like systemd and so on, in how they pick and build the user level tools, the command line tools, and then how they pick their graphical UIs and how they integrate that whole thing. So along that entire stack, there are many different choices, many different points you could make in this design space. And that's what I want to examine with all these claws. All right, so what are the layers of abstraction? You have the agent core, which is your core LLM reasoning loop. An agent is, after all, an LLM doing reasoning and tool calls in a loop until some task is accomplished. So that is the very core of it. That is, of course, using some LLM. And then on top of that, you can start building up your quote unquote user land or application level stack. There's a ton of code and logic that has integrations with various messaging platforms, Telegram, WhatsApp. You have your tool registry, of course, which is what lets the agent core actually perform actions. So what kinds of actions can it take? On top of that, you have memory and state. So these agents will remember your preferences, they'll remember your instructions, they'll reflect on previous conversations to extract insights and things to remember for future conversations. So that's another layer. And then security is really important. That's the thing that OpenClaw keeps getting beaten up for because it took a very laissez-faire approach to security. But if you're more conscious of this, you want all these things running properly in a sandbox so that they can't blow up your entire system. You can control what they have access to and so on. Another layer is how these things happen on a schedule. I think this was one of the core innovations of OpenClaw, this notion of a heartbeat, that it periodically wakes up and performs a bunch of tasks. And then, of course, you have configuration that ties all this stuff together, and you have a gateway API which allows some kind of outside control of this entire stack. And this is more for programmatic access or API access compared to the messaging platforms, which are for interactive access between a claw and its human. And so I went and did an analysis with Claude, of course, not all by myself, of OpenClaw and a few prominent claw variants that have arisen recently: NanoClaw, IronClaw, Nanobot, and PicoClaw. And you can see how they vary based on what kind of choices they've made in this design space and also how large they are. So NanoClaw is the smallest one, just around 2,000 lines of code. And the others, while they're bigger than NanoClaw, you can see how they're an order of magnitude smaller than OpenClaw. And that in and of itself can be a very appealing factor for many folks. Some are implemented in TypeScript, some in Rust, some in Python, some in Go. They've made different choices about what kinds of messaging channels they want to support, what kind of LLMs they want to support. And then I think the more opinionated choices come in at the level of what kind of tools these claws have. And the choice of tools is very closely related to what agent core they use. I think these two, while you can separate and modularize them to some extent, the agent core and choice of tools really go hand in hand. So famously, OpenClaw uses the Pi agent as its internal core agent. Pi is another agent that is very minimal, and it is itself broken up into other smaller packages, like its own set of tools, its own agent core, and so on. NanoClaw made an interesting choice that it simply decided to use the Claude Agent SDK, and it delegated its entire core agent loop to that. Others have built custom agent loops, as you see over here. And once you pick your core agent, you can then also pick what kind of tools they have. So OpenClaw is the most extensible one. You can keep adding tools to its registry. NanoClaw, since it uses the Claude SDK, uses the same mechanisms as Claude in terms of plugins, skills, commands, etc. to extend the tools it has. IronClaw uses MCP. So they're all making different choices here. You can see the exploration of the design space even in the memory layer. OpenClaw uses a vector database, but then a bunch of them just use simple markdown files. The security layer is interesting. OpenClaw, like we said, has a pretty lax attitude to it. The others use some notion of sandboxing and containerization to run workloads inside a secure boundary. Here's a diagram of the full stack. If you tear up this monolithic thing that is OpenClaw into its layer cake, this is what you'll see, this layer cake of abstractions as it goes up. And what I wish existed was a way that each of these could be independent packages, and then you can pick and choose from among these abstractions to construct your own, just like people pick and choose different things along the stack to make Linux distros, and each Linux distro has an opinionated take on why it chose the things it did. I think you could do something similar for the Claw ecosystem as well. All right, I hope you found that useful. I will leave a link to this full report in the video description. If you like content like this, consider subscribing, like the video, and I will see you in the next one. Thank you very much.